Welcome to part 4 of this lesson. We're going to continue immediately from the end of part 3, so let's get started. Okay, so to configure the outbound component of this integration, let's move back to the Route 53 console and select outbound endpoints towards the bottom left, and we're going to create an outbound endpoint. We'll call the endpoint name A4L outbound. This will also be running from within the AWS component of our architecture. So click on the VPC dropdown and select A4L-AWS. It's also going to need a security group, which is how we can secure these endpoints. So click in the dropdown and select the AWS security group. The outbound endpoints will use 2 IP addresses. So scroll down, select availability zone 1A, pick the private A subnet, and we'll let AWS assign the IP address automatically. For IP address 2, select 1B, choose private B subnet, and again, we'll allow AWS to assign the IP address automatically, and then click on Create Outbound Endpoint, and this is creating the outbound Route 53 endpoint. Again, this will take a few moments to create, so we'll need to wait for that process to finish. So go ahead and pause and wait for it to move out of the creating status. Once that finishes creating, it should show as operational, and next we need to configure the forwarding rules that will use this outbound endpoint. So go ahead and click on Rules towards the bottom left, and we're going to create a rule. We're going to call the rule A4L on-prem-corp zone so that we know the role that it provides. And then scroll down, and under domain name, we need to configure the domain name that this rule will forward queries for. So we need to use the zone that's located within the simulated on-premises environment. So this is corp.animalsforlife.org. So type that in. And then we need to pick which VPCs will use this rule. So it's going to be A4L-AWS. We want this rule to apply to all services within the AWS VPC. And then we need to pick the outbound endpoint that this rule will apply to. So click in the drop-down and select the A4L outbound endpoint that you just created. Now this rule is going to forward any queries for this domain name, and we need to pick where those queries are forwarded to. So we need to give 2 IP addresses. So click on Add Target, and we need to provide the private IP addresses of the DNS servers that are running within the simulated on-premises environment. So go back to the EC2 console, and we need the private IP addresses for on-prem-DNS-A and on-prem-DNS-B. So first, let's do DNS-A. So copy that into your clipboard. Move back to the Route 53 console and just paste that into the top IP address box. Go back to the EC2 console, pick DNS-B. Copy that into your clipboard, and paste that into the second IP address box. So what this is doing is it's going to forward any queries for corp.animalsforlife.org through to these 2 IP addresses. And these, just to reiterate, are the DNS servers running within the simulated on-premises environment. So go ahead and click Submit. That rule's applied and it's now active. So let's go back to the EC2 console, and we're going to test it by connecting to one of the AWS resources. Let's use EC2-A. Right click and select Connect. Choose Session Manager. Click on Connect. So now we're inside the AWS environment, and let's ping a resource inside the simulated on-premises environment. This will test the network connectivity and the DNS resolution. So type ping space app, so app.corp, C-O-R-P, dot, and then animalsforlife.org, and press enter. And now that we've configured the integration, it will resolve this name to this IP address, and because of the connectivity that we have between the 2 environments, that ping will return a response. So the architecture of this is that this query originates inside the AWS environment. It goes to the Route 53 resolver. Because we have those rules in place, the Route 53 resolver knows for any corp.animalsforlife.org queries to use these particular outbound endpoints. And then these outbound endpoints are used to forward that query through to the DNS servers running inside the simulated on-premises environment. And those are the servers that are providing an answer to the DNS query that we've just run as part of that ping. So we get the IP address back in response to that query, and then we can ping that IP address. And at this point, you've successfully configured integration in both directions between these environments. So you've configured inbound integration from the simulated on-premises environment into AWS using inbound endpoints, and you've configured the reverse, so integration from AWS to the simulated on-premises environment using outbound endpoints. And that's everything that I wanted you to do in this demo lesson. I hope it's been useful and you've gained some practical experience of how to perform a fairly complex integration of AWS and on-premises DNS environments. At this point, all that remains is for you to tidy up to put the accounts back into the state as they were at the start of this demo. So to do that, move back to the AWS console, select Rules, and then click on the rule that we've just created. It should be called A4L on-prem-corp zone. Select the VPC that it's associated with and select Disassociate. Now that will take a few minutes, so just pause the video and wait for that to finish disassociating. Once that has disassociated, then we can go ahead and delete the rule by clicking on Delete. This time you'll need to type delete. Once the rule's deleted, then you can go to outbound endpoints, select the outbound endpoint and click delete. Again, you'll need to type or paste delete into that box. Do the same for inbound endpoints, so select the A4L inbound, click on delete, type delete. Next, we'll need to delete the VPC peer, so click on the services drop down and select VPC. Click on peering connections. Make sure the VPC peer that you've got selected is the one between the AWS environment and the simulated on-premises environment. Click on the actions drop down, delete the VPC peering connection. Now, a new option with the recently updated console is you can actually select to delete the route table entries that you've created for this VPC peer as part of deleting the peering connection. So you can select delete related route table entries, and that will cause it to delete those entries when you delete the peering connection. Now I'm going to show you the process manually, so go ahead and click Do Not Delete the Route Table Entries. You'll need to confirm the deletion by typing delete into this box and then clicking on delete. And once you've done that, go ahead and click on route tables. And we need to edit both of these, so select the on-prem one, click on routes. We're going to remove these black hole routes, so click on edit routes. Click on remove next to black hole, click on save, then select the other one. Again, routes, edit routes, click on remove next to black hole, and click on Save Changes. Now we did both of those because we edited those route tables to point at the VPC peer, which no longer exists, and so we just want to make sure that we return those route tables into the same state that they were when they were created by the one-click deployment at the start of this demo series. And then the last step, click on Services, select CloudFormation, and we're going to delete the stack Hybrid DNS, so select it. And this is the stack that was created using the one-click deployment. So select that stack, click on delete, and then delete stack. And once all of that's finished, your account will be back into the same state as it was at the start of this lesson. With that being said though, that's everything you need to do for this demo lesson. I hope it's been enjoyable and I hope it's given you some good practical experience of how to operate with Route 53 endpoints. So go ahead, complete this lesson, and when you're ready, I'll look forward to you joining me in the next.